Okay, so I know the last couple lessons just seemed kind of like busy work, but it was, I was trying to give you problems that would help you explore more extravagant trig problems, I guess you would say. So I wanted to do that before we took the test, the last test right there. So hopefully that did help you with the test. Right now, as I'm making this recording, you haven't actually taken the test yet, but my plan is to try to still get to the test and grade it, even though I'm not officially in school. So hopefully I'll be able to get that back to you as soon as possible. It all depends on how I'm feeling. Okay, so normally what's going to happen from this point on, if we have a lesson, which will be like the next 2 weeks, I'm going to do this recording and I will put up the PDF of the completed flip chart after the recording. So the expectation is that as you go through the recording, so like right now, you could hit pause, do the warm-up, and then unpause and see me do the warm-up. And when I give you those cues to go ahead and pause the video and try it yourself, you have to have some self-discipline to go ahead and do that. It's not going to do you any good to just run through and watch me do all of the work. If I say that it's time for you to try it, then you go try it. Okay? So right now, you can pause the video and try the warm-up. Okay, so now you have restarted. I'm going to go ahead through and do the work on the warm-up. And I'm going to do it. I don't have it worked out in advance, so you can see my mistakes. You can see my struggles. You can hear how I'm talking through different problems. So these are all non-calculator questions, and it says exact value. So I'm guessing I need to use my exact value table idea for that. So I know that 45 degrees, the sine and the cosine were both equal, and they were at the square root of 2 over 2. And the tangent of 60 degrees, if I remember the line of tangent, it actually went 0, square root of 3 over 3, 1, and then square root of 3, and then undefined. So this, it was 0 degrees, 30 degrees, 45 degrees, 60, and 90. So that means that the tangent of 60 was the square root of 3. Find the exact value. Now, these are also no calculator, but these are listed in radians. I don't do so great in radians. Usually what happens is I convert them to degrees before, and then I work in degrees in my head. So I'm going to convert these to degrees just so I know what I'm doing here. So that's going to be multiplied by 180 over pi. Pi's will cancel. 3 goes into 180 60 times. So I'm looking at the sine of 120 degrees. So 120 degrees, the reference angle would be 60. So 120 degrees is sitting right here in this quadrant. And that means that's 60 degrees off of the x-axis. Okay, so I'm really looking for the sine of 60 degrees. And with sine being the y-coordinate, it will be positive. So that means this thing is actually equal to the sine of 60 degrees. And if I think about my exact value table, the sine of 60 degrees is the square root of 3 over 2. I'm going to do the same thing with the tangent thing over here. I'm going to go ahead and change this to degrees. So I've got 180 over pi. Pi's cancel. 4 goes into 180 45 times. And 3 times 45 is 135. So I'm really looking for the tangent of 135 degrees. Okay, and if I'm thinking about where that lands, that's 45 degrees off the x-axis this way. But in this quadrant, because the sine and the cosine are opposite signs, I'm actually looking at the negative tangent of 45 degrees. So the tangent is negative in the second and the fourth quadrant. It's positive in the first and the third. So I know the tangent of 45 degrees is 1, so then that makes my answer negative 1. I need to find the x-intercepts. It didn't tell me whether I needed to if I could use my calculator or not, so I'm going to go ahead and use my calculator. So I'm going to start a new document, and I don't save the old, and I want a graph, and I'm typing in 2x cubed minus x plus 5. And I'm graphing that. The maximum number of x-intercepts I'm expecting is 3, but looking at this, I'm only seeing 1. So then I'm going to do menu, analyze graph. I'm looking for the 0. and I have to put my bounds on one side and then on the other, and I get negative 1.48. That's an x-intercept. I'm going to do the same thing with this one. I'm just going to put in a new graph. I'm just taking out the last equation, and I want the natural log, which is above the e to the x button, and in the parentheses I want x squared minus 3. This one I'm seeing 2 x-intercepts, and I believe it's symmetric. So menu, analyze graph, I want the 0. I'm going to do the lower bound to the left and upper bound to the right of my first one, and I get negative 2. And then I'm going to find my second one, and I believe I know it's positive 2, but I just want to verify with the calculator to make sure. The 1, and you do the lower bound to the left and the upper bound to the right, and sure enough, it is positive 2. So my second one is 2, 0. Okay, so I want to solve these. Solve means find out what x is equal to. So I really don't enjoy that radical sign there, so how about I square both sides? So what this is going to get me is x cubed minus 5x quantity squared equals x plus 1. When all else fails, I could probably get it equal to 0 and then use my calculator and find the x-intercepts again. So by squaring this, I'm going to use the binomial square theorem. I'm going to square my first term, so that's x to the 6th. I'll multiply my two terms together, so I get negative 5x to the 4th, but I have to double that, so negative 10x to the 4th. And I'm going to square the last term, so I get 25x squared, and that all equals x plus 1. So like I said, I'm going to get everything over to the one side. So x to the 6th stays as is, negative 10x to the 4th stays as is, 25x squared stays, but I do a minus x and a minus 1, and I have that equal to 0. So I'm going to go ahead and graph it and get all of my x-intercepts on here. Again, the maximum I'm expecting is 6, because that's the degree of the polynomial. Okay, so it's going to take me a few seconds to type in. I've got x to the 6th minus 10x to the 4th plus 25x squared minus x minus 1. Go ahead and, ooh, sugar. It didn't come down out of the exponent after the 4. Let's try then plus 25x squared minus x minus 1. There you go, that's better. I'm actually seeing 4 x-intercepts. One, it automatic. It's a crazy looking graph actually. It looks like it goes up and down so many times. I have one a little bit before and after 0, and one right around 2. So the first one is already actually marked on my graph for me, and it says 2.040. So let's go find the other ones. Analyze graph, the 0. I need, this was one I should have done on Desmos. That would have made it a lot prettier. Okay, I need, just because this mouse is sometimes crazy on these calculators. Go get the smallest x-intercept I see. I'm getting negative 0.182. And that's 0. Menu, analyze graph. Let's find the other one. I'm getting a positive 0.223. 0. And that's 1, 2, 3. I need one more. There's actually one more. So this graph is, like I said, it's kind of crazy looking. If you didn't actually get to graph it, it goes up like this, then it comes down like this, and I'm assuming these connect up in here. And then another one comes even lower, so I'm assuming that connects up in there. I'm not seeing the whole thing, on my screen, but I'm making that assumption. Analyze graph, 0, and then with the last one. Okay, so mine wrote right over top of a whole nother one, so I gotta move some stuff out of the way. Oh, that's why it also looked confusing, is because it typed it over top of the 2.04, and it is actually 2.40. There's my 4 X-intercepts. Convert these measures to radians, so 45, I'm going to multiply by pi over 180, and that actually equals pi over, if you remember, that's pi over 4. Okay, 150 times pi over 180. 30 degrees goes into both, or 30 goes into both of them. So this is a 5 over 6. So this is 5 pi over 6. And then 270 multiplying by pi over 180. They're both divisible by 90, so I'm getting 3 pi over 2 for this one. All right, and I'm going to convert to degrees, so 11 pi over 12 times 180 over pi. The pi's cancel. And if you want to, you could actually use the calculator for this. You could just put in 11 times 180 divided by 12. You get 165 degrees. For 3 pi over 2, well, I just did that one. So I'm going to get that one as 270 degrees. I'm not going to redo that one. I know that. I'm going to use what information I have. But 7 pi over 8 times 180 over pi. The pi's are going to cancel. And I'm going to do 7 times 180 divided by 8. That's getting me 157.5 degrees. You can either list it as the exact 157.5 because it is exact, or you can round that to 3 significant figures and give me 158 if this was a test question. All right. So next, we are actually starting into chapter 13 today, and these are circular functions. So now we're not necessarily looking at the geometry part of trigonometry, but more of the algebra part of trigonometry. All right, so we're going to be looking at the definition of sine and cosine in terms of the unit circle, tangent. We have the ratios that we've already kind of looked at a bunch of this stuff. We have the Pythagorean identity, some double angle identities, relationships between trig ratios, the actual function, the trig function, the sine function, and the cosine function, and then some applications for it. All right, you can ignore that homework assignment. Obviously, we don't have homework, but what we're going to be learning is properties of the unit circle today. So I know, don't explode on me. I know it's a Ferris wheel, but it'll be okay, I promise. This is the London Eye, by the way. This is a picture of the London Eye. So you can see how large this thing is, okay? And what this graph over here is showing you is it's showing you the height of one of the cars. So let's say this one, as it goes around the Ferris wheel perimeter, right? So this spot right here corresponds to this spot. If I go a little further and this, let's say this car traveled up and was sitting here, that would be this spot on the graph, halfway off the ground, right? Now, if this car traveled all the way to the top peak, then it would be this far off the ground. What we're comparing is the time the Ferris wheel is turning compared to the height of one specific car, this one that we started with down here, okay? And this is the actual equation for the London Eye, okay? So we're going to be picking apart these equations. This is the cosine, but we're going to be picking apart these equations and finding out what each of those parts mean. Hopefully some of that will come back to you as we work through it. All right, so the unit circle has a center at the origin, a radius of length 1. The terminal side of the angle in standard position will meet the unit circle at a point with coordinates cosine, and sine. So we know the coordinates around the outside are always going to be in that order. The x coordinate corresponds to the cosine, and the y coordinate corresponds to the sine. Okay, and what that has to do with is the fact that we're looking at, you can see it best with one of these acute angles, we're looking at the distance in the x direction, that's your x coordinate, and the distance in the y direction, and that's your y coordinate. If you think about those original right triangle trig problems that we did, if this is my angle measure, that's x is my adjacent side, and adjacent was in your relationship with cosine. And looking at 45, this piece right here, which is the distance of y, is your opposite side, which was in the relationship of sine. Sine equals opposite over hypotenuse, okay? So it doesn't matter whether we're working in radians or degrees, the same thing is happening every time. The x coordinate would be the cosine of that angle measure, 45 degrees, or in this case, this one here, this was actually going a negative 4 pi.3, so we're looking at that angle measure. Okay. All right, so we're going to take some time to do the investigation here. The sine, cosine, and tangent on the unit circle. You can also use the unit circle to help understand the sine and cosine values. For the terminal side, you want to sketch each angle in its standard position on the unit circle and use your sketch, not your calculator, to help determine the sine, cosine, and tangent for each of them. Okay, so let me explain this. I'll do one, and then hopefully you'll pick up the pattern and be able to do the others. So, angles that are in degrees. We want to sketch that on the unit circle. Okay, so right here is 90 degrees. Okay, we know that that angle measure is 90 degrees. And we know that the coordinates, because it's a unit circle, the coordinates of that spot right there is 0, 1. So that's what we're looking for. We need to determine the sine, cosine, and tangent. So the sine of 90 degrees equals 0. The cosine of 90 degrees equals 1. And the tangent of 90 degrees is the sine divided by the cosine, is equal to 0. Okay, so pause here, do the rest of them, and then you can start it back up and check and see how you did. Oh my goodness gracious. I realized when I was putting the rest of the answers up that I had messed up the sine and the cosine and the tangent of 90 degrees. So I have fixed them. I have a habit of trying to write the x coordinate first, even though this was listed as the sine first. Okay, so there you go. That is fixed. And in blue, I've done the rest of the degree measures. And then in red over here, I kind of created somewhat of a table to do all of the radian measures. So if you need to check out and see if you got something right or wrong, go ahead and pause. Otherwise, I'll move to the next slide. Okay, so we've done this unit circle before. We should be able to put all the angle measures on. And then we should be able to also put all of, the angle measures in degrees. And we should also be able to go back and put all of the angle measures in radians. And we should also be able to put each of the coordinate points. So we're going to run through it real quick again and make sure we understand this pattern as it goes. I'm going to start with degrees. They tend to be the easiest. So I start on the outside. I put 0 degrees, 30 degrees, 45, 60, and 90. That's my first quadrant. I know those by heart. Over here we've got 180, and this is 30 degrees less than that, so that's 150. And then we got 15 degrees is always the difference between these two, so that's 135. And another 15 degrees would take us down to 120. All right, and then 30 more than that would take us to 210. Another 15 would be 225. And another 15 would be 240. And then this jump is 30 degrees, so that takes me to 270. And then another 30 degrees is 300. A little 15 there gets me to 315, and another 15 gets me to 330. And finally, I'm back to 360. All right, the next thing I'm going to do is I'm going to put radian measures on. Okay, so I'm going to do that in red inside. So this is 0 radians. And the 90-degree markers are actually each one is, well, this 180 degrees is pi. That's one of those relationships we already know. So if that thing is 1 pi, then splitting it in half would make this one pi over 2. So every 90 degrees is 1 pi over 2. So that goes 1 pi over 2, 2 pi over 2, which simplified to pi. And then this one would be 3 pi over 2. And this last one would be 4 pi over 2, which simplifies to 2 pi. Then I'm going to do the 45 degrees. So 45 is actually half of that pi over 2. So we're going to make that pi over 4. Every 45 degrees is a pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And notice that every time I hit a line that was already labeled, I just counted it and moved on. Okay, and those had already been reduced. That's why we started with the 90 degrees. Okay, and then the last one I'm going to do is increments of 30 degrees. Okay, and if I'm taking this whole pi and dividing it in 30 degrees, I have 1, 2, 3, 4, 5, 6. So it's a fraction over 6. So it's pi over 6 here. So that's 1 pi over 6. 2 pi over 6, which reduces to pi over 3. 3 pi over 6. 4 pi over 6, which reduces to 2 pi over 3. That was 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6, which can be reduced to 4 pi over 3. 9 pi over 6. 10 pi over 6, which reduces. 11 pi over 6. So really I just go through and I do it as my fractions. I honestly am picturing a pizza and how many slices the pizza's cut into. The last thing I want to do is to go ahead and put the coordinate pairs on. So I always put my 90s on first, and then I do the first quadrant because everything else comes from there. So this one right here is at the point 1, 0. This one is at the point 0, 1. And then we have -1, 0, and 0, -1. Okay, and then in my first quadrant, I'm going to put the cosines first. I'm going, and this is like your exact value table. Okay, so if 1 is here, then the thing that's next to 1, 1 less than 1 basically, was square root of 3 over 2. Square root of 2 over 2. Remember doing that in the exact value table? 1/2. And then 0. And then 0, we can count up for this one. 0 goes to 1/2. Square root of 2 over 2. Square root of 3 over 2. And 1. Now all we're going to do from here is go ahead and do reflections of those points and change the positives and negatives. So this one has the same y coordinate. Well, we can just do this. Positive, positive in this quadrant. This quadrant over here, the x coordinate is negative while the y stays positive. So that means I'm using -1/2 and square root of 3 over 2. Here I'm doing negative square root of 2 over 2 and square root of 2 over 2. And here I'm doing negative square root of 3 over 2 and 1/2. In this third quadrant down here, every coordinate is negative. All right. So we'll do this reflection, 150 to 210, and that'll take us from there. So that's negative square root of 3 over 2 and -1/2, negative square root of 2 over 2, and negative square root of 2 over 2, and -1/2, negative square root of 3 over 2. And in this fourth quadrant, your x is positive, but your y is negative. So we're going to reflect this 240 over to 300. It'll give us a starting point of +1/2 and negative square root of 3 over 2. Positive square root of 2 over 2 and negative square root of 2 over 2. And then and then square root of 3 over 2 and -1/2. That quickly. I got that whole unit circle filled out with radians, degrees, and sine and cosine. And I could, if I wanted to, I could do one more step and put the tangent out there as well. So let's see, our tangent's going to be in green. So the tangent is always the sine divided by the cosine. So this one is undefined. Okay? Sine divided by cosine of 30 degrees was square root of 3 over 3. This one was 1. This one was square root of 3. And this one was 0. Okay? And again, it's going to reflect. It's going to reflect. But what we want in this quadrant is the tangent is positive. In this quadrant, the tangent is negative. In this quadrant, the tangent is positive. And in this quadrant, the tangent is negative. So we're going to have the negative square root of 3, negative 1, negative square root of 3 over 3, and it's not negative undefined, it's just undefined. Okay, down here, everything's going to be positive, so I'm going to reflect this one. So that's positive square root of 3 over 3. That's positive 1. That's positive square root of 3. Okay, and over here, it'll be negative. Whoops, I missed this one. That will be 0. Over here, it will be negative. So negative square root of 3, negative 1, and negative square root of 3 over 3. There's every piece of information you'd ever want. Okay, so if you need a second to write it down, go ahead and pause. I'm going to go on to the next slide. But that way you'll have it in your notes and you could use it. But you should still get used to creating it yourself. All right. So we want to be able to do the exact value table again, just like we've done in the past. So angle measures, we'll start with 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Those radian measures are also 0, and 30 was pi over 6, and 45 was pi over 4, and 60 was pi over 3, and 90 was pi over 2. Notice this progression here. It's not really a complete pattern, but it kind of is. What I think about is how many times does this angle measure go into 180? 90 goes into 180 twice, 60 goes in 3 times, 45 goes in 4 times, and 30 goes in 6 times. That's what helps me out with that. So your sine of 0 degrees is your y-coordinate, so that is 0. And then we're just going to create it from there. 1/2 square root of 2 over 2, square root of 3 over 2, and 1. 0, 1/2 square root of 2 over 2, square root of 3 over 2, and 1. And when we go to find the tangent, we want to do the sine divided by the cosine. So that is 0. That is the square root of 3 over 3. Remember, I have that one and this one memorized. Just because I don't feel like I can't do that rationalizing in my head. So this way I have it worked out so I don't have to. And that one's undefined. So again, if you need to write that down or take a screenshot of it, feel free. I'm going to the next slide. Okay, that is just showing what we just did. So that's fabulous. All right, so we want to remember what we discovered about supplementary angles, and what we see is that the sine of 30 degrees is equal to the sine of 150. And that's because they are supplementary angles, because 150 plus 30 equals 180. Okay? And then the cosine of 150 with the negative cosine of 130 are equal. Okay? And again, that's because they're supplementary. So with the sine, it's the same. With the cosine, they're opposite signs. And we've already gone over the fact which quadrants are what. This quadrant is positive, positive. This quadrant up here is negative x, positive y. This one down here is negative x, negative y. And over here we have positive x and negative y. Okay? So a lot of this stuff is review, which that's great. Tangent. This is a relationship we use all the time. Tangent is equal to the sine divided by the cosine. So here we are. Find 3 other angles with the same values. So another angle with the same as the sine of 35 degrees. Let's see what I can get here. Let's see if you can find them. And then I want to find 3 other angles that equal the cosine of 35, and then 3 other angles that equal the tangent of 35. Okay, so take a second and do that. Go ahead and pause, and I'll put up the answers. Okay, so here are my answers. You can see what I did with the sine of 35 degrees is I showed that in the first quadrant it would be here, and because it's the y-coordinate, the equal y-coordinate would be a horizontal reflection of that. So I wanted either a point that terminated, an angle that terminated here or an angle that terminated here. So the first one I said was 145 degrees, so that's this one. And I started looking negative, and I could go negative to that line, and that was negative 215, and negative to the original line was negative 325. When I did the cosine of 35 degrees, I recognized that that's the x-coordinate. So the other x-coordinate that has the same sign is in the fourth quadrant. So along with 35 degrees, negative 35 degrees would work. 325 degrees would work. And negative 325 degrees would work. For the tangent of 35 degrees, I needed to recognize that the opposite quadrants, 1 and 3, would have the same values. So I have 35 degrees is equal to the 180 plus 35, which got me the 215. But I could also do this negative angle, that one right there, which is negative 145, and I could do the negative angle that brought me all the way back to the original point, and that would be negative 325. Okay, so that's an interesting way to look at those. So here's 3 very good relationships that we want to remember. It's not something that's in your formula packet. But the sine of any angle is also equal to the sine of 180 plus that angle. And that's the idea that this angle is going to equal this angle because we're talking about the y value. The cosine of an angle is going to equal the cosine of the negative of that angle. And the reason that happens is because if we go 10 degrees this way, we could also go 10 degrees that way and have the same x-coordinate. And the tangent of any angle is equal to, so here's my angle here, is equal to 180 degrees plus that angle. And that's because those two would create that straight line of 180 degrees. So those relationships are kind of what we just looked at a second ago. All right, where are we on? 12? Okay. I think one more slide of work. All right, so given that the sine of 50 degrees is 0.766, 3 significant figures, find the values of the cosine of 50 degrees. Okay. So whenever I'm given the sine of an angle, I need to find the cosine, or given the cosine, I need to find the sine. My first reaction is to use the Pythagorean identity. It's not necessarily something we've gone over yet, but you did in trig and you did in algebra 2, so it should be something that's in your wheelhouse. All right, so for letter A, I'm going to use the idea that the cosine squared of 50 degrees plus the sine 0.766 squared, because that's the sine of 50 degrees, that all equals 1. Okay, so now I'm going to pick up my calculator and do some work here. So I'm going to do 1 minus 0.766 squared. I'm going to get that over to the other side. So that's still, I'm at cosine squared of 50 degrees is equal to 0.413. But I'm going to leave that in my calculator because that's rounded off. I don't want to get a rounding mistake. So the next thing I'm going to do is take the square root of both sides. So I'm going to do the square root of my last answer. And it's giving me that the cosine of 50 degrees is equal to 0.6, oops, have you ever done that? Said a number and written a totally different number? 643. Okay? Now, because we did the square root up here, this is, and I should have left myself space for that. When we do the square root, we get the positive and negative of that answer, 0.643. Okay? So if I know the cosine of 50 degrees, okay, so looking at letter B here, B is asking me then to find the cosine of 130 degrees. Well, let's think about that. Okay, so I know what the cosine of 50 degrees is, and the cosine is my x-coordinate. Okay. So, and actually I need to go back because we are talking about 50 degrees. We only want the positive of this. Okay. So I know that the cosine of this one is 0.643 from that problem up there. Okay. And 130 degrees is the same 50 degrees off of the x-axis. So it is actually going to have the opposite x-coordinate. So I'm going to put in here that it's going to be the negative of 0.643. Okay. Next one is asking for the sine of 230 degrees. So let's think about where 230 degrees shows up. 230 degrees shows up right here. And it's asking for the sine of that. So it's actually asking for that y-coordinate right there. Oh, well, we were given the y-coordinate of 50 degrees, right? So this was 50 degrees. And the y-coordinate was 0.766. So if that y-coordinate is 0.766, and this is also 50 degrees this way, that means this y-coordinate is the negative of that, negative 0.766. Here you thought you were going to be doing some computation, but truthfully, you're just doing some comparisons here. All right, and the last one it gives us, let's pick another color here. The letter D is it wants the cosine of negative 50 degrees. All right, so it wants the cosine, which is the x-coordinate of this angle right here. Well, isn't that going to be the same as the x-coordinate of that angle right there? So we know this one is 0.643. So wouldn't it make the leap that that's 0.643? 0.64 in that case. So it's really just making the comparison of the different angles that add up there. Okay, so what comes next is your closure. There's your closure. It's written as an assignment. You can go do the assignment and submit it, and then that'll be all for today. Okay, hopefully this is going to work out. If not, we can figure out something that might work differently. I'm not sure how to handle this, truthfully. Okay, but thanks.